Hello sir, this is Safiya Khalid and today I'll be presenting the topic Additive Manufacturing. First, before we start talking about additive manufacturing, let us look into the topic called manufacturing technology. Right from the term given here, manufacturing means to produce something, and technology is the usage of scientific and technical processes so that we can produce that particular object. Now, the main objective behind manufacturing technology is to improve the efficiency, quality, and productivity of the operations. Generally, we say that there are three main pillars of manufacturing technology. The first pillar is subtractive manufacturing technology, the second one being formative manufacturing technology, and the third one, additive manufacturing technology. The first and second manufacturing technologies are traditional methods, and to cite examples, for subtractive manufacturing technology, it includes turning and milling, and for formative manufacturing technology, it includes casting and forging. In this particular project, I'll be dealing with additive manufacturing, which is a fairly new and budding technology. Now coming to the main topic of discussion, which is additive manufacturing. From the term additive itself, we understand that we are adding something in order to create a final object. I've divided the definition of additive manufacturing into three main components. The first component being layer-based. Now, additive manufacturing is a layer-based technology in which whatever final object that we intend to create is done so in such a way that it is created layer by layer, starting from bottom to the topmost layer. Second component, which is automated. Additive manufacturing is an automated process, so we're not going to be using any machinery or any physical strength in order to create the object, like how we do in subtractive and formative manufacturing. Instead, all the details regarding the final object is fed into the computer system using the 3D CAD software. This includes all the dimensions, coordinates, etc. Hence, we're not going to be using any tools like already stated, and the final object which we're going to be receiving is a scaled three-dimensional physical object. So based on whatever data is fed into the computer system, the final object will be exactly satisfying all those details, the dimensions, coordinates, etc. Therefore, in short, if I have to define additive manufacturing, it is a layer-based automated fabrication process for making scaled three-dimensional physical objects without the usage of any 3D part-making tools. I'll now be discussing about the additive manufacturing process chain. The entire process of additive manufacturing is carried out in a series of steps which is having a particular order. Therefore, it gets the name process chain. In the first step, what we'll be doing is using a special software called CAD, we'll be creating a virtual design of the intended product. Since it's a virtual design, it's also called the digital product model. In the second step, again, it's carried out in the computer and using specialized softwares, in which whatever product we've created, the same design is taken. Whatever product we've created virtually, it's taken into the next software, and this design is sliced into different layers, and each of these layers will be having the same thickness. Let us call the thickness as dz. Now, the main purpose of this step is that we've already learned that additive manufacturing is a layer-based technology. Therefore, in the next step, wherein we'll actually form the object physically, the object will start forming from the bottommost layer and will start growing into subsequent layers. For this, each layer's information should be obtained, and this is done by the slicing method. Also, this gives the contour information. Whatever I've explained now, the technical term will be contour. For example, if this is the bottommost layer, it's having a particular length and a particular shape. Similarly, any layer in the middle or the topmost layer, it also has a particular dimension and a particular shape. It means that these two layers have been contoured. They have specific shape and dimensions. So this information is obtained from the second step. In the third step, this 3D data set is taken and fed into the machine with which we are going to be creating the physical model. As stated earlier, this data sheet, it consists information about the thickness. Generally, all the layers will be of the same thickness, dz. It will also contain information about the x and y coordinates of each layer, and also the total number of layers that we need to be creating using the machine. After this is fed into the machine, two steps take place in this. The first step is the physical contouring, that is production of each layer of specific shape and dimensions. This happens again from bottom to top, bottommost layer, and then the model keeps growing till the topmost layer. And the second sub-step which occurs in this third step is merging. Once each layer is obtained, it is merged with the next layer. As a result of this subsequent formation of layers and merging, we'll get a physical object. In additive manufacturing, whatever the final object we achieve or we are obtaining, it is called as part. And the first step, whatever digital design we are creating, it is called the digital product model. Nomenclature of AM machines. Nomenclature simply means the way in which something is named. AM machines are named based on two criteria, or there are two types of nomenclature of AM machines. First one, based on the type of products that they produce, and the second type of classification or naming is based on where they're used, the location where they're used in. So based on the first criteria, the AM machines are of two types, fabricators and prototypers. Fabricators, from the name we get to know that they are able to fabricate the final product. On the other hand, prototypers, they're only able to produce the prototypes of the object we're looking for. Since AM machines, they are able to produce the final product in terms of layers, and it's as if we are printing a 3D object. They're also called as 3D printers. Now, based on the second type of classification, which is based on the location they are used in, the AM machines are of three types. The first one being fabbers, the second one being office machines, and the third one being shop floor machines. Fabbers, they are used at homes and other personal spaces, and since they're used by individuals or group of individuals in their own space or in their own personal space, it's also known as personal fabbers. The second classification is office machines. From the name, it says that it is used at offices and they're operated by office staffs itself. Since they're used at offices, the special features of these machines is that they emit less noise, smell, and particles. Also, another feature is that they are easy to use and the cost of handling everything is very minimal. Also, the waste disposal is very easy. We needn't segregate the waste produced from these machines. It can just be disposed along with the normal office waste. Also, once the build material in these machines gets over, we needn't call for any officials or anything. Just like how in normal printers, when the ink gets over, it's refilled by using cartridges. Herein, the build materials are also available in the form of cartridges, and they can just be replaced by the office staffs. Now, the third type of AM machines are called as shop floor machines. These machines, they are used in industries, and the main difference between these and the first two varieties is that the shop floor machines, they require specially trained and skilled operators in order to make them function properly. Also, since in industries the production is usually done in a large scale, the main purpose of shop floor machines is for high output and productivity, and here the important feature is that the production should take place economically. The next topic of discussion is the types of additive manufacturing process. There are three main processes which we'll be discussing. First one is SLA, second one is FDM, and the third one being SLS. The first one is SLA, which stands for stereolithography process. This is the diagram of the SLA process, and the components include the laser source, which is a UV laser source, a platform which is controlled by the elevator. The movement of the platform up and down is controlled by the elevator. It consists of a tank called vat, which is filled with photopolymer resin. And above the platform there is a layer of resin. So just like any other additive manufacturing process, SLA, the first two steps remain the same. We're going to input the design in the computer using the CAD software. The second step, it is sliced. The design is going to be sliced. And the third step, the 3D CAD data sheet is sent into the 3D printer setup. So when the laser source receives this information, it starts injecting the laser beam on the surface of the resin, and the required pattern gets created on the resin. Since resin is a photopolymer, when UV comes in contact with the resin surface, it gets cured, and as a result of the curing process, that particular layer gets hardened and it dries up. So once the particular layer is created with the help of the elevator, which is again controlled by the input 3 data sheet, the platform moves down. Once it moves down, again the laser source starts injecting the laser beam on the next surface of the resin, and the next layer gets created. So for example, if this is the first layer being created, with the help of the platform, the first layer moves down. Again, the top layer gets filled with the resin, and with the help of the laser beam, the next layer also gets cured. So the main application of SLA is rapid prototyping. Rapid prototyping means the creation of prototypes instantly or very quickly. Prototypes are nothing but the miniature models of the final product. Other applications of SLA process includes creating concept models and also models which have very intricate geometries. In this way, layer by layer with the help of the UV laser source, we'll get our intended final product. The next type of additive manufacturing process is SLS, or Selective Laser Sintering process. In this case, the base material will be in a powder form, and this powder form can be of plastics, glass, or ceramics. Now, sintering means the application of heat onto that powdered form so that it first melts, and then when it solidifies, we'll get that particular layer in the solid form. In this case, the different components of the SLS process includes a carbon dioxide laser source, a laser scanning mirror, which is used for reflection purposes, a feed roller or a leveling roller. It consists of powder cartridges on either sides of the part build chamber, and this part build chamber is where the final product gets formed, and then it consists of the descending platform. Here the carbon dioxide laser source, it will be the source of heat which will result in the melting of the powder. So first, when the input 3D data sheet is given to this 3D printer, the carbon dioxide laser will be incident on this mirror, which will then inject the laser beam into specific locations of the part build chamber to start the production of the layers. So before that happens, from the powder cartridges, the powder will be emitted or will be ejected on this surface, and this roller will help in the transfer of that powder correctly to the part build chamber. So by the time the laser comes and gets incident on it, the layer formation starts taking place. So after one type of this, the roller will be in this position, and again the powder will be injected here, and this powder will be pushed towards the part build chamber with the help of the roller. So once the one layer is finished, with the help of the descending platform, that layer is pushed down, and the powder comes and occupies this position. Again, with the help of the laser source, the next layer is created. In this fashion, the entire product will be created. The last type of additive manufacturing process is FDM, or the full form is Fused Deposition Modeling. In this case, the raw material which is used, it will be in the form of a solid wire or in the form of a filament. The most commonly used raw material is ABS, or the full form is acrylonitrile butadiene styrene. The components of the FDM process includes a filament spool, which feeds the filament, feed rollers, and this is the chamber where the heating element is present, and through which, once the filament passes, it gets converted into the semi-molten form, a nozzle for the outlet of the heated filament, and this is the descending platform, which helps in the movement of the platform in the vertical direction. Another point is that the nozzle and this heating chamber has the capability of moving towards the left or right for the formation of the product. So the process takes place in this manner. The filament spool will feed the filament, which then passes through the feed rollers and into the heating element, and here it gets converted into the semi-molten state. Through the nozzle, it comes out, and the first layer starts forming. If we want to increase or decrease the dimensions, this is controlled with the help of the leftward or the rightward movement of the heated filament chamber. Similarly, once the first layer is completed, with the help of the descending platform, it moves down, and subsequently again the filament passes through all these steps, and the next layer starts forming. In this way, in a matter of considerable amount of time, we'll get the final product.